In this video, you'll get an introduction to tools and methods for analyzing model performance in LandingLens. You can use these tools to help identify how you can improve a model. To showcase these tools, I'll walk through an example of an object detection model trained to detect dolphins and whales. After you train a computer vision model in LandingLens, you can compare the ground truth labels to the model's predictions directly on the images. The solid line represents the ground truth, and the dotted line represents the model's prediction. For example, this whale was labeled and the model correctly predicted it, although with a slightly different bounding box. And here, a whale was labeled, but the model misclassified it as a dolphin. If you're building a proof of concept and don't have many images yet, just scrolling through the thumbnails can give you a good indication of what labels need to be fixed or what classes might need more images. The high-level model metrics display in the model tile. This includes the F1 scores for the train, dev, and test sets. It also includes the number of false positive, false negative, misclassified, and correct results. For example, the model predicted most objects correctly, but given that the false negative numbers is high, it looks like it's not predicting objects that are labeled. To dive a little deeper, click View Confusion Matrix. This opens a pop-up with more detailed performance metrics and the confusion matrix for the model. At the top, you can choose to see the F1, recall, and precision scores by set. Below, you can analyze the confusion matrix. The y-axis represents each ground truth label, and the x-axis represents each possible model prediction. Each cell represents a ground truth and prediction pairing. For example, the confusion matrix shows the model correctly predicted the class whale 24 times, misclassified it as dolphin once, and missed it 7 times. In general, you want to see all the numbers go in a diagonal line down across the chart like in this example, because that means that each prediction matches each ground truth. If any off-diagonal cells contain values, you can start by looking at the cells with higher numbers to understand what the model might be having trouble with. For example, let's look at the predictions for whale. While the model misclassified a whale as a dolphin once, it didn't predict a whale at all 7 times. I could do a few things to fix this, including checking that all the whales are labeled correctly, adding more images of whales, and removing any images that might have noise or aren't a good representation of a real-life use case. The confusion matrix also shows you the precision and recall scores by class. For example, the precision score for whale is 100%, which means that every time the model predicted a whale, it was correct. By contrast, the recall score for whale is only 75%, which means that the model correctly predicted only 75% of the whales that were labeled. To look at even more granular model performance details, click the View Full Report link. This opens the model's performance report. The performance report shows you the same metrics like the F1 score and confusion matrix, except that it's specifically for an evaluation set. By default, you can drill into the train, dev, and test sets, and you can add more evaluation sets from the Models tab. So let's go back to the Build tab for a second. Here, I notice that the F1 score for the dev set is low compared to the other sets. To figure out what's causing that, I can go back to the Models tab, click the dev cell, and see the confusion matrix just for those images. Based on this chart, the error the model made the most for the dev set was not predicting dolphins. I click this cell, and the images with this error display below. The left image shows the ground truth, and the right image shows what the model predicted, which in this case was nothing. Now, if I hover over the images, I can see all of the labels and predictions, which shows that the model did get some of the predictions correct. This could indicate that maybe I need more images with overlapping bounding boxes so that it can learn from these patterns. On the left side of the pop-up is a table that shows all of the ground truth and prediction pairings. I can click a row to filter the images by that pairing. Another way to analyze the results for the evaluation set is to click Analyze All Images. For object detection and segmentation projects, this shows a side-by-side comparison of the ground truth labels and the predictions on the image in the dataset. You can click an image to see a larger version. And that is an overview of the key ways to analyze model performance in LandingLens. Use these tools to understand and improve your model. Visit the Landing AI documentation and community for more resources.